These are the Meta Ray-Ban display glasses, the next evolution of Meta's smart glasses announced today at their Connect conference. While they don't provide full augmented reality, they have a full-color heads-up display embedded in the right side lens. They're also the first product to make use of a neural wristband to control the glasses interface, reading micro gestures from your hand that feels like a brand new computer control paradigm. We went for a deep hands-on with both the glasses and the neural band to dissect how these technologies work, and once again sat down for a technical conversation with Boz, Meta's Chief Technology Officer. Boz, good to see you 1 year after you showed me Project Orion last year.
That's right, and we're back with more exciting things to show you. Thanks for coming back.
Absolutely. You alluded to it last year. You guys were working on not just like a time machine, a glimpse into the future, but products that people can actually have. And I guess we're seeing that now. You guys are announcing at Connect the Meta Ray-Ban displays. Tell me, how do you see this product? It's not a time machine? Is it mainstream? What is it?
Yeah, this is the beginning of mainstream, I think. Now, certainly, you and I both know there's been people who've played with glasses and displays before, and I think some of them really executed pretty well. There's a couple big challenges that I think they didn't manage to accomplish, which is, it's a valiant effort this early on in the development of a life cycle. But one of them is the inputs. And I think one of the things that gave us so much confidence in this product was the success, frankly, of Orion last year as it relates to the band. Obviously, when everyone thinks about, oh, you're going to have these augmented reality glasses, which we really do envision, they think a lot about the technology required to generate the display, which is exquisite. But if you can't control it, it's really not worth it. It's not worth all the extra weight and cost. And so this is really what I think unlocks the device for us. And the second piece is the style and design of it. And we were lucky to get again once to work with our partners at EssilorLuxottica, and really they helped us shape it so that not only do you have the functionality, but you feel like you look good while you're using it.
That's a really interesting partnership because they have this long experience with knowing what the consumer wants, and you guys have a lot of success with Ray-Ban Stories, Ray-Ban Meta being something that looks like a standard pair of Ray-Bans. So the design becomes a constraint, right? You have only so much volume, only so much space, but you want to put a lot of technology in these.
That's
Can you
right.
walk me through how you guys ended up in the display, all the tech that you have in now these pair of glasses?
Yeah, I mean, once we realized that your primary use case was going to be artificial intelligence, suddenly a smaller field of view display that was higher resolution made a lot more sense.
Yeah.
If I'm going to be asking the AI questions, instead of waiting for it to kind of slowly read the answer back to me, I can get a high-res, written version of the answer on the display. That's pretty useful. And it's a little different than how we've historically thought of augmented reality, right? We're not trying to create overlays on top of artifacts in the real world, which we really still believe in the long term, but we have this beautiful, useful product in the interim. And so for us, we chose a geometric waveguide, which allows you to provide a tremendous amount of resolution and brightness, especially kind of per unit thermal space that you have in the glasses, even though it's a slightly smaller field of view. But it's a custom LCOS projector. And then for us, we went to work building around that key component, taking as much as we could, obviously, from the lessons we've learned from building Ray-Ban Meta now for years, into ultimately a product that we're quite excited about. And part of the story of this is when we started this project, our partners at EssilorLuxottica were a little skeptical that we'd be able to get it into a form factor that they'd be confident enough in to partner with us in the design. And then we showed them, I think, a year and a half ago, maybe, where we were. They were really enthusiastic to partner with us on getting the most important pieces for us. It's not just does it work well, but do you look good when you're using it?
Well, I'm sure the prototypes are much bigger and bulkier, and it doesn't look necessarily like a pair of glasses. And this display engine, because you're talking about it's a monocular display, right? Just on
That's right. Just on one eye, just in your right hand eye.
Right. And the reason for choosing that is that
yeah. Well, there's a bunch of reasons. When you double the display, obviously some things are trivial. It doubles the cost and the weight, and that's all true. But it's not just that. You also start to get disparity between the eyes. So if there's any kind of flex between the two lenses, if you see these have a little give, and that's actually a feature. That's something that you really want in your glasses. That becomes much harder to manage. Now you're having to add sensors to account for that disparity and processing power to correct for it. So going to binocular, which I think, in the distance you kind of expect to be more and more standard, it's not free. And we played with, as you can imagine, we played with every version of it. We played with binocular, we played with monocular, we played with different fields of view, we played with different brightness levels. And this was one that we felt, from a standpoint of what we could deliver at a very competitive price point, was going to be a very compelling offer.
Yeah, manufacturing, that's the whole thing. I remember when chatting with you about Orion, just the rigidity of the frames.
That's right.
So important to lock in, again, the disparity, any binocular for binocular vision, using silicon carbide for the wide field of view.
That's right.
You don't need to have necessarily that wide field of view if the use case here is information at a glance.
That's right, 100%. And also, in moving to less exotic waveguids allows you to have a much higher, production confidence in the amount of volumes that you can produce.
Can you talk about that, your partner, how you got to this implementation of geometric reflective waveguides? And I know you guys have, prototypes and all sorts of different technologies, but why this type?
Yeah, well, geometric in this case, and listen, as you think about geometric waveguides versus reflective, where you're starting to unlock higher fields of view, and you're getting thinner, but at the exchange of a much more kind of complicated manufacturing process, a higher risk in yields and volumes and quality assurance as you time on. Once we realized we had a product that we felt was going to be a great product, and the premium was on resolution and brightness, so you can take this and read text outdoors.
Yeah.
And once the premium wasn't on field of view anymore, you're in a totally different solution space than what you're thinking about when you're thinking about augmented reality. Full augmented reality, I have to have a huge field of view, because if my artifacts are constantly getting cut off, I'm being taken out of that immersion of the synthesis of digital and physical. Yeah. And so it's actually a much easier solution space. There's a lot more options when you're going for that target, but it's not trivial. And we really felt like none of the immediately available commercial options were right for us. And so we had to bring some of our additional expertise to drive up the quality of what we could deliver from the display.
So you have those parameters of what the user experience can be with the
That's
display and this form factor. Talk about developing software for this. What type of experience did your team come up with? What are the pipe dreams? How open can this be?
Orion was really a tremendous unlock for us, as we kind of predicted it would be. Once you have Orion, you can start to get into the iterative loops of what it's like to use the neural interface as the major interface control mechanism that the consumer is using. And so once we started playing with Orion, that made leaps and bounds for us in terms of how we conceptualized what was possible in Hypernova. The software and use cases today are a little bit bounded by what we can do thermally on the device and inside the compute window, especially given that we want to give people long all-day wear. Yep. But over time, this is just the beginning. I think it's going to be, everyone's going to take this device and immediately see where things are going to go in terms of third-party ecosystem. And that's both conventionally, sure, there are apps running on the device, but also more forward-looking, how artificial intelligence could ultimately become a much more powerful tool for us to navigate a large third-party ecosystem of capabilities over time.
As you think about the suite of applications, I did some demos. I got to do like a navigation app to get directions somewhere. I had to use things with Meta AI. Is the priority for you and your team to find ways to tap into Meta AI in novel, interesting ways using this, or more of a traditional suite of applications you'd find on a smartphone?
Yeah, well, starting initially, we want to take use cases that are already popular for people on their phones and make that even more accessible. So messaging, obviously a major use case that you're using your phone for. Can you not only read your messages, but also through the handwriting that we're unlocking on the wristband, be able to reply quickly for messages that don't require a lengthier reply, or obviously if you want to be able to dictate or over time do more synchronous communication, you can also do that. Likewise, there's even things like the camera. Okay, such a popular request from Ray-Ban Meta is I wish I could see the picture I was taking.
Live view.
And so now we've got the ability to do live view, and you can do that for photos and for videos. You can zoom in and zoom out, and so you can have a greater kind of selection of what exactly you're focusing on in your image. You're not just stuck with the same wide angle image that you get. And so if you listed probably the top 5 or 6 things that you're doing, music. I want to change the track. I want to change my playlist. If you're picking the top 5 or 6 things that you're doing today on your phone, that's what we optimize this device for. So you can do all those, keep your phone in your pocket, and still be engaged, hopefully, in your surroundings.
Yeah, yeah. It's technically interesting. I'm realizing now it's technically two wearables. You're wearing
It really is.
the glasses as well as the neural band. You guys seem really confident that glasses are the best way to interact with AI. Like, what gives you that confidence? Not everyone wears glasses, and
Yeah.
how much did you consider maybe putting more of the tech in something you wear on your wrist?
Yeah, it's not the only way, and I don't think we feel like glasses are the only path here. I think it is an incredibly convenient place because almost by definition, glasses on your face, they have access to what you're seeing, they have access to what you're hearing, which for a contextual AI over time is almost certainly the key to understanding how to be most useful to you. And likewise, obviously, they're an incredibly convenient place to give you information through a display or through speakers. So there's a reason that glasses are so attractive. But of course, you're right. Not everyone wears glasses. Not everyone wants to wear glasses. And as a consequence, I do think over time, there will be more form factors and more places for you to interact with your AI. And that's very exciting. But for us, making sure we focused on a wrist wearable that was comfortable, all day wear, comfortable, and you weren't going to have to be fiddling with it or fussing with it or worrying about it. It's not going to go compete with if you already have a smartwatch, if you already have something that's deeply integrated into an ecosystem, that's fine. This works completely, with the glasses, so it's totally fine for that to be the case. And then focus on what we've already been pursuing for such a long time, as you know, in the glasses form factor, but it's not the only thing we have going.
Yeah.
I won't say more than that, though.
Okay, all right. I mean, glasses are also, and wearables in general, very personalized objects, right? And a lot of customization that goes into them, not just for the practical benefits, but also for aesthetics, right? How do you guys think about personalization, customization, durability? If someone's going to be expected to wear this, an $800, $799 product for years, how is this going to last as long as a notebook or other device?
Yeah, for sure. So there's two different angles to this. I mean, from the how people look perspective, we think a lot about this. And so if you look at, for example, the evolution over time of, we started with just Ray-Ban Stories and then Ray-Ban Meta. We really started to build out the different styles. Now we've got the Houstons. Now you've got the, the Vanguards. Thank you. One of the problems I have is you play with all the internal code names so much that you sometimes forget the actual names of the products that when you launch them. So you see us starting to branch out in styles. And I think the same thing will be true over time with display glasses. So we care a lot about providing people the options they need to feel like, hey, these glasses represent me the way I want to be seen in the world. Yeah. The durability side, it's very conventional consumer electronics combined with wearables. So there's a tremendously robust, suite of tests that are being provided by industry for wearables that have been going back a long time. So, as we progress, suddenly these are IP67, so we have a good construct of, okay, what kind of tests they've been submitted to, going to 3 feet depth and being exposed to a certain amount of time underwater and that kind of thing. So all of our glasses, you want to make sure that they're robust to being in the rain. They're robust to being, if you get hit with, a water gun, like they're not going to immediately have a problem. They all go through kind of the same kind of conventional drop testing that you would expect both consumer electronics and conventional glasses to go through. They're not, by all means, they're not indestructible. They certainly can and will break, and we have systems for customer support for those things. But it's all very conventional. And from a mechanical and electrical complexity standpoint, the main really novel piece for glasses like these, and even the Ray-Ban Metas, is the hinge. And so that's where we're really lucky to partner with EssilorLuxottica, who has a tremendous amount of experience designing hinges to last. Yeah. And so they've been able to work with us in the design. So we've got these kind of great overmold hinges that allow you to have a great deal of comfort, both putting on and off, and then keeping it snugly on your head.
Yeah. Well, now that you have displays, is the genie out of the bottle in terms of, do you not want to ever think about glasses without displays? Is that?
No, we actually think these all exist in a spectrum. I mean, first of all, we feel amazing about the price that we've gotten these down to. To be able to launch these at this price is nuts. People do pay more than that just for conventional glasses, prescription glasses from high-end brands. So we're very excited about the price we've gotten these down to. It's still a lot of money. And there's still people who want to be able to participate with artificial intelligence. They want to be able to take the photos and listen to music and be at a lower price point. So we're very excited to be able to serve them as well. We think the entire spectrum is going to exist. And then in the future, we think there's going to be a market for, at the higher end, full augmented reality glasses that provide even more capability. So we are not pursuing one of these to the exclusion of the others. We see them as a suite that all can work together. and kind of provide every consumer with the right product for what they need.
You're selling these as a bundle or a combo. Do you ever see, because I know they can function technically without necessarily neural input, I guess, do you ever see these glasses, is neural essential to this use experience, to this type of product category, or is this even more robust that you can see this being an input for other types of devices?
Yeah, I love that. So there's two different answers to that. The first one, I mentioned before, the thing that gave me especially so much confidence in this product was the neural band. I mean, it's one of the things that just like, once I started using the neural band with Orion,
Yeah.
I was like, this is exactly how I want to be able to interact with these devices. So we felt so strongly about it that yes, we did couple them. Even though you're right, we did design this product to be fully functional. If the neural band goes out of batteries, we don't want your glasses to suddenly not work. So you've got a 4-way touchpad on the arm. You've got the ability to control through your voice. So you've got other ways that you're able to control the device. But by far, the best way to do it is the band. We felt so confident about it that we'd made the bundle. And I think you're absolutely right that as this band, people start to use it, we are going to want to use it for more things. Yeah. I'll tell you, I've had the experience already that I've been using the Meta Ray-Ban displays. Again, I'm about to use the code name. In my personal life, when I put on my Ray-Ban Metas and I go out, I'll accidentally do the gestures to control things via the display, and I'll realize, oh no, I can't. I can't use to. I have to do it the other way. Yeah. So it really does become a second kind of nature to do it, and then you start to realize, why couldn't this be a platform to control more things in my life, not just the glasses that I have in my face? So I think there is a lot of upside over time for these types of interfaces. Yeah,
they're Meta Ray-Ban displays now. You guys swapped the names. Ray-Ban Metas. What does that mean for you?
I mentioned this previously. It's one of the things in our partnership with EssilorLuxottica. We really developed these glasses expecting them actually to not get the Ray-Ban badge, and not out of any disrespect or anything problem. That's a badge that really means something from a design and aesthetic standpoint, and Luxottica keeps a careful control over that. And so they supported us. They were like, yep, go nuts, go build it. It looks amazing. Let us know how it goes. It was pretty late in the program that they were like, oh, wow. I think we actually can find the styling and the design that's going to deserve to have this display. So we see this as a real a joint collaboration in a way. And so for this one we switched it. It's Meta Ray-Ban displays.
All right. And I got to wrap up by asking about Orion. You guys have had a year now with your teams working on it. What have been some of the lessons learned? What can you share about manufacturing? What have you learned about the possibilities of Orion?
Yeah, when you launch a new technology platform like Orion, it's really hard to see past the horizon. It was really hard for us to know what effect Orion would have on us until we put it out in the world last year this time. And I'm so thrilled it's had this tremendously positive effect. It's led to the design, interface, interaction design that you're seeing now in the Meta Ray-Ban display glasses. So you're starting to have some public benefit from it. It's also led to a tremendous focusing of our energy on knowing what we want the targets to be for long-term full AR glasses, in terms of field of view, in terms of display resolution. And so, it's really focused and sharpened our roadmaps. It's also given us a lot of confidence. The reception to that product was really positive, and our own experience using it was much more positive maybe than we even anticipated. So that gives you a lot of confidence to go out and make those investments. So it's not just, okay, we've talked about how expensive silicon carbide was for the first generation prototype of Orion. Yeah. And you kind of face this question like, hey, should we be investing a bunch more to make that a more scalable process? Once you get the experience, you say, yes, we should definitely be doing that. But not only that, should we pursue other avenues so that we have multiple display options? Yeah. So you increase your confidence. That gives you a lot of ability to invest with confidence in not just one solution, but a range of solutions, so that when the product comes into focus, a year from now, we're starting to be able to down select from lots of different options to optimize the product experience that we want to have. And finally, the third piece of it is from what the software needs to be, what kind of processing power do you need to provide the software experience that you want? And so the entire system architecture really gained a lot of focus and conviction following the launch last year.
You remain optimistic, it's still your North Star.
Very optimistic. Yeah, more optimistic than we were maybe at any point previous. I mean, I think Maybe not day one, maybe you're super optimistic, and then over the course of 10 years of investing, doubt does creep in over 10 years. You start to wonder. And so a renewed conviction, I would say.
Awesome. Thank you so much for your time, Buzz.
Thanks for having me.
Okay, so there's a lot to talk about with the Meta Ray-Ban display glasses, as well as the Meta Neural Band that they're launching at Meta Connect today. And I wanted to run through what this product is, the technology behind that new display, as well as the neural band, and then go through my impressions of all the demo experiences I was able to do on site last week when I previewed these glasses. Obviously, I'm recording this a couple of days before Meta Connect, so new information might come to light. Things might be announced on site right now. So I'll do my best to do a follow-up video, and we'll be hopefully reviewing these glasses when I get more time with the final product. But there's so much to talk about. Let's first talk about what these glasses are and how they work compared to the current Ray-Ban Meta glasses, which is what I'm wearing and what I have here right now. When I saw the Orion prototype last year, Meta was really proud of the fact that those glasses look kind of like your standard, thick rimmed glasses that someone would wear, but I knew and they knew they would be too thick for a mainstream audience. And you need to get that form factor much closer to your standard pair of Wayfair or Ray-Ban sunglasses or Oakley sunglasses at this point. And so I'm happy to report that looking at the Meta Ray-Ban display glasses, those look much closer to the Ray-Ban Metas. They're slightly bigger dimensionally. And if you look at the arms, the biggest tell is the arms are taller and thicker to accommodate electronics, the light engine, as well as the battery, but it's all self-contained. There is no additional control processing puck, battery puck, or anything. All there is that extra control interface with the neural band. They have a lot of the same characteristics as the Ray-Ban Metas. So a camera, single camera still, it's on the top left. The top right, which looks like a camera lens, but it's not, is still a notification light for people out in the world. So when you take a picture or record a video, it's gonna blink and glow white. It has the higher resolution cameras as the new Ray-Ban Meta Generation 2s and the latest Oakley glasses, so up to 3K video, although they didn't say it's the exact same recording characteristics as those glasses, probably somewhere in between. And then they do also have a dedicated shutter button on the arm on the top right. Although I've always wanted, after using this for over almost 2 years now, a 2-action shutter button. I want something where I can depress halfway to lock in and get focus, or maybe in this case, bring up a live view of what I'm taking a picture of, and then fully press for it to then immediately capture and shutter or start a video. But still, single action shutter button, manual shutter button in this case. The glasses are a little bit heavier. They're 69 grams. That's compared to the 50 grams of the Ray-Ban Metas and 45 grams of your standard Wayfarer sunglasses. And when I put them on, it was a little bit noticeable. I could tell 60 was a little bit heavier. I'm so used to wearing these and the fit of these glasses that I could definitely tell it was heavy, but didn't feel like it was heavy. I wouldn't call them heavy. I could just feel that they were heavier. But the biggest difference is actually the hinge system. If you look at the Ray-Ban Metas, these are standard Wayfarer hinges, standard glasses hinges. You can even see, the exposed screw there that you can do to tighten it up or repair. The hinge system on the Meta Ray-Ban displays, completely different. It's actually further down along the arm, and it doesn't just fold this way. It actually bows outward, which I think is going to be one of the best attributes to these glasses, because I've seen a lot of people report that after wearing their Ray-Ban Metas, they're not perfectly fitted. They can cause some damage in the hinges. I've seen some damage in the electronics because of stretching of the hinges, and just having that extra flex outwards on both sides, further down the arm, I think is going to make them more comfortable and more durable over long periods of time, because these are expensive glasses I should be holding on for years. For me, though, it did feel a little looser, maybe, than my Ray-Ban Metas because of the extra bowing. So I could see myself adding some extra bit of, a bit of rubber on the arms or something under the nose just to keep it up, because I did feel myself wanting to push up the glasses even more so than before in that demo time wearing those Meta Ray-Bans.
Finally, something that Meta Ray-Ban owners might notice is that there is still a notification LED on the inside of these glasses. On the Ray-Ban Metas, they're on the left or on the right side. On the Meta Ray-Ban displays, they're on the left side, and that's also where the physical on and off switch is. You also have open-ear speakers in the same place as before, so largely it looks just like the current Ray-Ban Metas, just slightly enlarged, slightly heavier with that new hinge design. It has a reported 6 hours of battery life. That's according to Meta themselves with regular use, and it will have a charging case. And the charging case is actually a much better design this time. It's a collapsing foldable charging case, so it folds up much tighter, smaller volume, so you can easily put it in a jacket pocket or a bag. The current charging case I find to be a little bulky, that I don't carry it along with me all the time. It's something I put maybe in my backpack. Sometimes I keep it in the car to charge, and this thing I can actually see myself having on my person. The charging case does not actually charge the neural band though. That comes with a separate charger that you plug in, but it's all bundled in the same package. But of course, the biggest differentiator is the fact that it now has a display, a single display, monocular, full color display over and embedded in the right lens, kind of like on the bottom right here. So I wanted to spend some time diving into the technology of how that display works and how it compares to other augmented reality or display glass solutions. Okay, so to talk about the display inside the Meta Ray-Ban display, I brought a little bit of a visual aid. Let's talk about the characteristics, the features of this display first. It's a monocular single-eye display. It's full color. They tell me it's 600 pixels by 600 pixels and across a 20-degree field of view, which is going to be important for how they engineered this. With that pixel density combined, they say it's about 42 pixels per inch, which is much higher than even on the high-end VR headsets, where you're seeing 30, 35 pixels per inch. Although to my eye, in looking at the images through this, it didn't look like it was as high as 42 pixels per inch. I could see photos, I could see video, I could read text, but the text was a little bold. There were definitely ways they were making that glowy text more readable. It didn't look like looking at my phone, for example, a high pixel density phone up close. But definitely good enough that information was very readable in this square. And even though it's 600 pixels by 600 pixels, a lot of information felt like it fit more within a 3:4 aspect ratio, taller than wide aspect ratio frame. It is a fixed focal length image, so the image floating in the lens looks like it's about 1.25 meters in front of you. That's closer than the about 1.5 meters a lot of VR headsets are fixed focal length at. It's not very focal at all. And it does support prescriptions built into the optics itself. The demo unit I use had inserts that were based off of my personal prescription attached, but for people buying this, they actually have to go to the store, send in their prescription, and it's going to be made to order, or at least assembled to order based on their specific prescription, up to +4 and -4 diopters, although no idea whether it will support astigmatism. And to get this relatively bright image, they're talking about 5,000 nits of image that works both indoor as well as outdoor, because transition lenses are mandatory. They're built in. They will dim a little bit, turn into a little more sunglasses in bright light to make the image more visible. To make all of that work, they had to choose a very specific type of waveguide display. Waveguides are a way of embedding a light engine or light source or image source into the frame and then projecting it directly into the lens itself. So unlike the birdbath style optics that we saw on these X-Real display glasses, these are more akin to the waveguides that we saw in previous AR implementations like HoloLens or Magic Leap. But its implementation of waveguides very different from those AR glasses and very different than Project Orion, the Orion prototype that I saw last year. So I want to talk about the different types of waveguide implementations. If we think about the components of a waveguide, on the fundamentally, we're talking about two things. We're talking about a light engine or a light source, an image source, and as well as you're talking about the type of waveguide that's embedded or etched onto the lens itself. So in this case, they're using an LCOS, that is a liquid crystal on silicon light engine, and that's different from the micro LED, a light source that they had in Orion. That was a RGB individual light source. LCOS gives you a sharp image at very high brightness, and this is combined with a reflective or geometric waveguide. Most of the AR implementations we'd seen in the past were diffractive waveguides, and that's including Orion. So let me diagram this out. If you imagine this lens flipped 90 degrees flat, and so the topography of the lens something like this. And this could be a bunch of different materials, plastic, glass, or in the case of Orion, that's silicon carbide. The way a waveguide works is there is actually a physical imprinting or etching onto the lens itself. And so you have one here and one here. And so this grating is what's called the input coupler. So light comes in on this side. We'll draw some arrows for light. It actually then bounces in through the lens, and then it exits through an output coupler here. The angle of acceptance, the degree in which light can enter this coupler, is determined by two factors. Determined by one, how much of a field of view you want in the output coupler. So if you want a wide field of view, you need to have a wide angle of acceptance for it to have a wide exit output coupler for wide field of view. But the material of the lens itself also is a big determining factor. So the index of refraction, that's this quality of different lenses that we talked a lot about last year, the higher index of refraction you have, the steeper the angles you can get of light inside the lens. The steeper the angle of light, the sharper these angles, the wider your angle of acceptance can be, and wider your field of view. That's how Orion was able to get that relatively wide field of view, higher than your 50, 60 degrees. But when you're talking about something like Meta Ray-Ban display, they didn't aim for higher than 20-degree field of view. And so having that constraint by design means they don't have to use silicon carbide. They don't need a lens with a high index of refraction. It also means that the way they do their waveguide input coupler, this doesn't have to be a traditional grating. And so for a diffractive waveguide, what you might see, for example, is you might see a light source here. That's called a micro LED, or maybe lasers. That's what HoloLens uses. And you would have light travel in through your waveguide here. And then light goes this way, propagates and expands this way. And you have your field of view for your image. In the case of Orion, because it was using RGB, you actually can do tricks. You could actually have not only your gratings on one side of the lens, you could also have gratings on the other side of the lens, and aligning them becomes really important to make that image not look blurry and look crisp. But you lose a lot of light with this way of using a diffractive waveguide. A lot of calibration has to happen. You lose it with that expansion. You lose it when it travels across the gratings here. The way that Meta Ray-Ban display does its waveguide is it actually has a series of prisms, 11 of them, that are actually really visible when you look at the lens. And those act as mirrors that take care of this first input coupling. So light travels down here and then bounces and propagates, expands this way, and then you have your image right there. Because the prisms and the mirrors are actually much better at bouncing the light and they're visible, they don't need to be hidden, you retain much more light and you get more of the actual image from your light engine, and you have less artifacting with that finished image as well. There's a big question in whether they'd be using reflective or diffractive waveguides, and even if they were using reflective waveguides, these geometric waveguides, whether those prisms would be along, which axis they would be along. There was some guesses that we would see the line of prisms up here, and then you would have the light expand down this way. But in retrospect, it makes total sense that they would have them actually over along this way, because they actually want the image to be in a kind of that lower field of view. That's why, for me, the image isn't, I'm not looking up to look at the image, I'm slightly looking down to see that image, that display. All right, so benefits of it, of course, high brightness, sharp image, and most importantly, as the viewer is looking at this, you actually do not see any of that kind of chromatic artifacting, that glow that we saw even with the Orion glasses that you kind of see with other AR glasses. I know Google showed off some prototypes at I/O of their augmented reality glasses, and you could clearly see in the TED Talk and in their video of that glowy box that became their display. As I was wearing them and chatting with the people giving me the demos who were also wearing the Meta Ray-Ban displays, I could not see the displays light up or any type of visual artifacting, any type of light bleed from the outside, even when those displays were on. And a lot of light also passes through. Transmissibility, also a big feature. And they're telling me about 85% transmissive. So wearing these glasses felt like I was looking through a normal pair of glasses. It didn't look like sunglasses. They weren't tinted. They weren't dark. They're not like these birdbath optics. I was getting almost as much light from the real world as I was getting from the light engine itself. I hope that gives you somewhat of a better understanding of how these display technologies work. Reflective waveguides are not cheap to manufacture. Neither are using L-cost light engines. And so that's why when you heard Boz, it sounded like he was really proud of the fact that they got this to that $800 price point. And that's because I could bet the majority, the bulk of the cost is in the yields for the display engine. But there's more technology in this than just the display. There's also the neural band. So let's talk about that. So let's talk about the Meta neural band, which in and of itself is also an interesting piece of technology on the level as the display in these glasses. And what's really interesting is that it could have been completely optional. Meta had acquired this company, Control Labs, that had developed these EMG wristbands for input based on hand movements, based on small micro movements, and presumably it was for input for VR headsets before their hand tracking got pretty good. And it made its way into the Orion prototypes I saw last year. And in chatting with the engineers and the product managers back then, it was pretty clear how confident they were in these neural bands to now make it into their big launch this year. And again, not an essential accessory, but feeds into their belief that the combination of these technologies, they display a HUD that gives you information at a glance combined with micro gesture input that does not require your hand to be within field of view of any type of cameras, that type of user experience, that user interface plus user experience, that combination can be really powerful, can really be compelling as an alternative to holding a smartphone, looking at a laptop, or even wearing a smartwatch. So what are the things you could do with this neural band? Well, when you first put it on, you have to choose which wrist you want to put it on. And in the onboarding, they ask you to put it on your dominant hand wrist. So if you're right-handed, put it on your right hand. Although they did say that you can technically wear this on your non-dominant hand, although your movements will maybe have to be a little more discreet, a little more determined so that the muscles actually register. I chose just my dominant hand. And the fit is a little bit tight. I mean, it is tighter than maybe how some people are used to wearing their watch. If you wear a watch with linkages and you like to kind of like fidget with it and have it roll around your wrist. You can't do that here. It didn't hurt, it wasn't pinching my wrist, but I definitely felt its presence there. And if you look at the clear prototype that they showed me, you can see that there are sensors not just at the bump on the top, but sensors all along the band itself, which it's going to need to read those signals from, electrical signals from your muscles. But just like last year, I wanted to try a variety of gestures, and not just the type of gestures, but how deliberate of a movement did I need to make to activate those gestures. Let's talk about what types of input you can have. So standard, there's a tap to pinch, like we saw last year. Tap your thumb and index finger to basically click. You can tap your thumb and middle finger to go back or deselect. Tapping the middle finger twice wakes the glasses from sleep, wakes the display up. And then most cool and interestingly, you can also put your hand in a little bit of a fist and you can swipe your thumb up, down, left, and right, and that almost acts as a two-way D-pad, the equivalent of swiping the two-axis touchpad on the temple of the glasses this year. And even more so than my time with Orion last year, I felt like these gestures had to be intention and deliberate, but not forced. I didn't have to overexert myself at any time to make these gestures. They could be very light taps. They didn't have to be exaggerated at all. When I was doing that two-way D-pad, I didn't have to clench my hand to a fist. It could be relatively relaxed, and as long as I move my thumb up and down, left, right, the success rate, the hit rate of those gestures was almost 100%. I rarely reach a spot in my demo where a gesture did not actually activate and trigger the intended movement. One new gesture that I got to try out was the ability to put my fingers together, either the index finger or the middle finger, and then turn my wrist as if I was holding onto a volume dial and rotating it. And here it actually acted as a slider or a dial to, in music playback, increase my volume or decrease my volume, or in their control panel to increase or decrease my brightness. Super responsive and super cool. They told me that the neural band has a polling rate. It updates every about 10 milliseconds, which is really frequent. But I felt like maybe in that dial, it was granular, but not as granular and as smooth as maybe swiping a slider on a touch screen, for example. It was maybe definitely more granular than the incremental volume adjustments you get today with the Ray-Ban Metas, the volume control. But I think there is maybe some improvement there, that even though the polling rate is high, that it's not there. There's some fuzzy signal detection to not have it be perfectly smooth, but nevertheless, very, very cool. It felt like by the end of my 30-minute demo that I was doing the gestures on the neural band almost subconsciously. I mean, it was really intuitive, a user experience, and I already felt comfortable doing the double tap to wake the glasses. The only thing I felt like I needed to train my brain more on was the swipe gesture on using my thumb, because it's kind of like using a trackpad. You know, I wanted mine to be inverted as opposed to swiping my thumb to the right to move an icon or move a cursor or move a selection to the right. I want to feel like I was putting my finger on a trackpad or on a touchscreen, and when I move my finger to the right, I want actually to be swiping the UI away to the right and maybe moving that selection to the left. So basically, if you like inverted trackpad options on your laptop, they actually have that as an option for you to toggle to invert your left, right, and up, down of movements, which is good to hear. The coolest demo, though, that they showed me, but I wasn't able to actually do, is handwriting recognition without holding a pen or actually writing on a piece of paper. But I did get to see in action with the person giving the demo running it. So they put their hand on their lap, and they pretended to write a sentence to me in English, and I don't think it was cursive. I don't think it was all uppercase either, but standard writing a sentence out, no pen in hand, and they told me without having to train the system specifically to their handwriting, it actually recognized, and in the demo I got, accurately presented the sentence they were able to write. This is going to be open for people to opt into as an early access feature in a beta program, but not something that's going to be a default feature. But the fact that I didn't have to do any calibration to do any of the gestures, while wearing the neural band. And the fact that they told me no training was required to get that handwriting recognition to work tells me that the accuracy of what they can do with the neural band, the ceiling is really high. I mean, we saw some research papers and videos in the past of control labs, researchers wearing 2 neural bands and touch typing on an invisible QWERTY keyboard, and that's not something they talked about or showed here. But the potential for having these robust gestures without actually having to hold physical controllers, or to be able to do these gestures with micro gestures discreetly, hands behind their back, hands in your jacket pocket, without necessarily having your hands in the field of view of any type of camera system, is really cool, which speaks to why Boz hints at the fact that their confidence in this product has them thinking about how these bands could be used as input devices for other types of computing platforms in the future, not just display glasses. Let's talk through my demo experience. I had about 30 minutes wearing the Meta Ray-Ban display glasses and ran through a selection of curated demos with their team, talking with someone who was also wearing a pair of these glasses. Now, they asked me first to activate the glasses using that double tap with the middle finger. It woke up the display and it popped up in my lower right field of view. And the first thing I saw was kind of a home screen of sorts. It was this list of icons, a grid of icons here, 2 wide by 4 tall, 8 icons. And I saw all your standard applications that you would expect. Here, a camera app, a music player app, a messaging app, and here also a navigation app. And they had me run through a few of those. They also had me run and swipe to the right and left from that home menu. So swiping it over, I was also able to see a control menu. This is kind of the equivalent of swiping down on your phone. So this control center was a shortcut to music, a shortcut to some favorite applications, as well as direct access to brightness and volume. This is where I did some of the demos of twisting my hand as a volume knob. But the first actual application they had me do was music. And this is your perfect case of a feature that, to me, already worked really well without needing a display. I listen to music all the time in the Ray-Ban Metas, but now having a display, I could see the list of music, I'd see album art, see playback controls, and more directly affect that playback using the gestures. So I had the ability to scrub through, even change the volume of the music. And here, something I noticed was volume got a lot louder on the Meta Ray-Ban display than it did on the Ray-Ban Metas. These are over the ear speakers, actually speakers that are pointed at your ears. A lot of people get confused and assume that these are maybe bone conduction speakers. They're definitely not, in-ear noise canceling at all, but they're just little speakers on the temples that point in. And the ones on the new glasses, I felt were a little bit louder at their loudest. Moving on from music playback, I was also able to activate the camera app. Again, a feature that worked fairly well without any type of display, but they said one of the things that people want from these are a way to preview your images that you took or preview them in real time. So activating the camera application with the neural band showed up a rectangle, and here I could see at a decent frame rate the actual image that the camera on the top left was seeing. Not only could I frame the image and take a picture with a gesture, but I could actually also tap and twist and then zoom in, digitally zoom and get in pretty well. They said this camera is basically the equivalent of the newest cameras they have on the new 2nd gen Ray-Ban Metas and the Oakleys, so higher resolution than what's currently on the Ray-Ban Metas. Again, a nice to have feature that's much better than kind of awkwardly positioning, taking the picture, pulling up the Meta AI app, and then syncing to the Wi-Fi on the glasses, downloading a picture before previewing them. So if you like taking pictures with your glasses, you're going to love this. Then there was messaging, and of course they're going to promote their first-party messaging program. Meta has WhatsApp, they have Facebook Messenger, and while these glasses will support your OS native messaging app like iMessage or Google Messages, what they demoed for me here was WhatsApp. And so I got into a conversation with WhatsApp. They had someone send me a message, and I was able to use my voice to respond via voice over text. And having that visual feedback of what my message was sent also useful. I also was able to do a video call. So here, someone dialed me using their front-facing camera, and I could see them as a little inset here. But like with the Vision Pro and screen sharing, I was then also able to share what I was seeing as well and activate my camera, the LED, of course, lit up, and they could see the camera here in a live view. And this is where it was a rectangle for them and maybe inset view. So I could see actually both a preview of my live view as well as what they were sending me, making most use of that screen real estate. Could see this being pretty useful if you're calling a family member or a friend, if you're at a restaurant looking at a menu, if you're at a store looking at a shelf of items and you just want to quickly share what you see in front of you, or just going for a walk or something. Again, these kind of features that we took for granted on our phones now built into the glasses form factor. From the video call, the next few applications were basically making use of Meta AI, because we know these glasses are a big push for them to integrate their artificial intelligence as an assistant into your everyday life. And currently, I do use some of that Meta AI feature with the Ray-Ban Metas for checking some basic facts. And it's easier for me to check something trivial, like trivia, using that than pulling up my phone, opening Google, and typing a question. It's really handy if I'm chatting with my son and he might have a question about something he's really into, dinosaurs, volcanoes, vampires, and I can quickly make a query, get the information, relay it, and not break the flow of that interaction necessarily by bringing out a phone. It's kind of the equivalent of, go chatting with an AI assistant in a speaker, but here it's built into your glasses. And getting that visual representation of the answers and the feedback, it's nice. I get that information more quickly without having to listen to it. But I wasn't able to see if I could turn off the audio. What would be nice would be to get that answer, that query response in display only and not have to have any audio response, to not be as much of a distraction. They also had me take a look at a painting and take a picture of it and have the Meta AI give me a description of it. And here was where they had some Meta AI follow-up links that I could click. So if you're familiar with browsing through Facebook, for example, you might see a post and there's generated Meta AI suggested follow-up queries that you can make to learn more about certain different things. They had the equivalent of that underneath the response, underneath the queries that I was giving to the glasses. Then here's where I felt like I didn't necessarily need those or necessarily want those. I want information at a glance. I want responses at a glance. It's not a time or place for me to dive deeper into information, go into any type of Wikipedia rabbit holes in these display glasses. If I want to do that, I'll take out my phone, I'll go to Wikipedia instead. They did also show an interesting application in navigation, which isn't a type of service that Meta typically provides. They don't have a Maps app on any devices. But here, there is a Maps app. It's tied to a query, so you can make a question of like, find me the nearest coffee shop, and it'll then show a top-down view of a map with a bunch of locations. You can select the location, and then it will draw a walking path to it, which makes sense. It's kind of like the equivalent of what Google Glass did years ago with navigation and directions. Although no haptics here to give you an indication of left or right turns. And in the demo I had, the compass orientation maybe wasn't precisely calibrated, so it wasn't pointing, it wasn't shifting the map as I was turning to point forward and realign me. So maybe that's something presumably they'll fix in the final version. The next demo they did, once we got to our virtual coffee shop, was a transcription, a captioning demonstration. So I was sitting across from a presenter, and they simulated a noisy cafe shop. They had other people start chattering to give the room a little bit of a buzz. And as I was talking to the person, they were talking to me, the directional mics were pointed to them. What they were saying would then appear as a live caption on screen, kind of like dictation you would use on your phone. And it was very directional. When I was looking at them, it would show me what they were saying, although it did pick up on occasion a few words that I was saying as well would get interspersed in there, my kind of responses. But they see this as an effective way to have a conversation with maybe to improve on someone's ability to have a conversation in a noisy environment rather than kind of the noise cancellation features that you would get on AirPods. And speaking of AirPods, the day I did the demo was when Apple announced the AirPods 3 with live translation. And so it was curious to me that live translation, even though it's a feature that has made its way into Ray-Ban Metas, was not something they gave me a demo for on site with these display glasses, which tells me maybe they're not super confident, or maybe not, it's not as ready for prime time yet. But they did say features like live teleprompter review would be something coming where you could feed it some text or some notes and have that displayed in front of you. And here's where that low light leakage, that high transmissibility of not being able to see that glowy artifact of that display from the outside world would be a real useful thing, to have that text be displayed while not being distracting to the person or the people you're talking to. But speaking of applications, everything they showed me was first party. I mean, I asked them directly whether they had plans to open this up as a kind of a platform for developers to create apps for, and they told me they were kind of cagey about it, but they said not really. They're going to announce partnerships with companies, select partners, to give them API access to create, curated apps, but this is not an app store launch. They're not launching these as a developer kit for people to create all sorts of HUD applications, which is really interesting to me. They're really either confident in the display technology or in their internal team's ability to deliver all the utility a person spending $800 on a pair of display glasses might want, rather than opening this up as a platform. And what was not there that I really wanted was that kind of lock screen with widgets information at a glance. The kind of information that you'd see looking at your smartwatch with, what Apple calls complications. I want the ability to double tap my middle finger and have the time, the battery life left on the glasses, some real-time information like stocks or sports scores. Oh my goodness, real-time sports scores, or my next calendar appointment, a selection of things that maybe I can curate right on the display at a glance. That would be so useful. Just give me that timer, give me that stopwatch, give me a way to program a feed of things that I want that are most useful to me, because what I want to see on the screen is going to be different from everyone else wants to see on this screen. And hopefully this is something that their teams are thinking about, and it's just still early as they are, quote unquote, still growing the ecosystem. So it tells me that maybe this is not a dev kit, that they're not looking at this as a dev kit, that even though Boz says this is the beginning of mainstream, it maybe isn't really a mainstream device yet. Certainly the fact that it's still relatively a high price point for most people. It's a luxury item at $800. The fact that you have to make an appointment and go to a physical store at launch to even order these, there's going to be no direct sales, tells me that it might be supply constrained, that because they seem like they're really proud of the price, that this actually might be a really expensive device to make, that the yields for these reflective waveguides in the neural bands are low. And they really want to see these glasses as a way to plant the flag in the ground, to be the first company with their own AI to be in the market with display glasses that takes advantage of that before Google does it, before Apple does it, and to really get a sense of how people use these glasses. More so than ever in the past year, have people come up to me and ask me if I was wearing the Ray-Ban Meta glasses. Maybe that's due to their aggressive marketing campaigns. They had that Super Bowl ad at the beginning of the year. But more people are realizing this is a thing. They've sold millions of these already. And when they announce this at Connect, as they're doing right now, people are going to be aware that these will also have a display. And the user interaction, the way people who are wearing these interact with the real world, can make or break this platform and this form factor, as it did with Google Glass. Even in the short time I had with this, and even in the video as you're watching how I'm using it, you'll notice that as I'm looking at the display and as I was watching other users look at the display, it's noticeable. There's that little bit of a glance down to what looks like the lower left, my lower right. And obviously I was trying to pick out the pixels and pixel peep and look at the information, but I'm darting my eyes back and forth. It's almost, maybe we'll call it something like resting HUD face or something, where, what is that look where it looks like I'm kind of lost, but not focusing? Can you have a conversation with someone in real time and still be glancing at it and it not be awkward? These are the questions that we just won't know until the Meta Ray-Ban with displays and these category of displays are more out in the world. So I'm really excited for them to make it out there so we'll kind of have a better understanding of what this will look like. I'm certainly really excited about the neural bands and the potential there. And you heard it in Boz as well. He hinted at the fact that they see that potential as well, and that these neural bands could make their way as accessories in other devices that aren't display glasses. But that's what's being announced today. There's no VR hardware at Meta Connect. I did get an opportunity to chat more about VR. That will come out in a future interview in another video. But if you have questions about these new Meta Ray-Ban display glasses and the Meta Neural Band, please post them in the comments section below, and I'll do my best to answer them. Thank you again so much for watching. I'm Norm, and I'll see you next time.